Well, hello everyone. I hope you can all hear me just fine. Maybe just ping in the chat room if you can. Perfect. Excellent. Okay, cool. So you can see my video, and I'm just really showing my face so you can see I'm not a recording. Hello from Cape Town, South Africa, or Hermanus, South Africa. Ron, you can switch me over. Okay, cool. So I'm calling you from Hermanus, South Africa, which is right at the tip of Africa. It is 9 o'clock and about 28 degrees Celsius here at the moment. So I'm not wearing very much clothing as compared to maybe our friends in Toronto and Canada. And today I'm going to be talking about Datomic and the 4 years that we've spent with it. So I am the CTO at Cognition. We started our 8th year this year in February. So we've been going for 7 years. We can't really call ourselves a startup anymore. We're more of a stay-up. And I just hope to share some of the lessons we've learned with Datomic. So we've been using Clojure and ClojureScript since April 2012, and Datomic since September 2012, which is about 2 or 3 weeks after it actually came out. And we've been in production with Datomic since Jan 2013, which means that we've got quite a lot of data so far. Over 50 million transactions across all of our production databases. So we've learned some things and we've seen some things in doing this stuff. So before I jump into the meat of my talk, I just wanted to take this opportunity to say thanks to some people. First of all, the Clojure community. Our company really would not actually be going today if we didn't have this Clojure community. We wouldn't have been able to react to all of the market pressures we had to. Without the awesomeness that is the Clojure stack. And I also wanted to say thanks to Ryan and the ClojureRemote 2017 team for this. Living in South Africa, it's pretty much impossible to get to conferences, and so this is a great way to do that. And thanks to all of you for listening and watching. And there's a special thank you for these people who actually made Datomic. And I was actually quite surprised to see how many people there actually are. I thought that the team was quite a bit bigger than this, but it's actually a small, tight-knit group, a bunch of people that Ryan used to work with a little while ago. So if you see them, out and about in the Clojure community, say hi. Okay, so in terms of questions on this talk, I have quite a lot to go through, but we'll see if we've got time at the end. So I don't want to take questions throughout the talk. But what I would like to suggest is that we have a Datomic kind of a Wild West session. So Ryan, if you wouldn't mind starting a poll, and then if people watch, if they find that they remain interested and would like to kind of dive into some of the details, then vote for that poll, and we'll see at the end we have an unsession to do. And finally, I just want to disclaim that I'm just a normal Datomic user. I don't work with or for Datomic or have any kind of insider knowledge. I probably will get some things wrong, and if I do, please correct me. Okay, cool. So there's kind of two parts to this talk. First, I want to talk about the underlying Datomic data model. Having taught a number of people to use Datomic over the years, most of our staff, technical staff, have been trained on the job rather than coming to us with existing Clojure knowledge. So I've taught this a number of times. And I've found that what I'm about to show you is really, really helpful in terms of getting up to speed with how to use Datomic, how to reason about the problems you're actually trying to solve with Datomic. So we'll dive quite deep into the underlying data model. And then once we come back out of that, I'll share a kind of a grab bag of tips and tricks and gotchas that I hope will help, especially the people who are just starting up with Datomic. And hopefully, you'll get some value out of at least one of those two sections, if not both. So to the Emacs Mobile. So, I should go to the very top of my screen here. So what I've got running here is just a Clojure REPL, and I'll push all this code live once the talk is done. I basically just got a Clojure REPL with an in-memory Datomic database, and all I'm working with here is the Datomic API. There's no other special code running here. I've just got an in-memory database. I've got a couple helper functions for working with that database. And just to see that it is there, we can see that we've got a live database we can work with. So I'll just scroll down here. I'm seeing a request for the font size, so I'm going to try. I'm using a hack to get the Fira code font running here, and I'm not quite sure. So let me try very quickly. 16, I think it is there. We'll try that or just live with different font size. Is that better, Anatoly? Or do we need to go bigger? Cool. So let's go with that for now. Okay, cool. So essentially, when understand, okay, well, let's do it even bigger. I see there's another request bigger. 20. That should be good. Okay, so really what I'd like you to get from this talk, or this first part of the talk, is the understanding, understanding how Datomic stores its data. Once you understand how it, how the data lives on disk and in the indexes, and how once it comes out of the index into memory, once you understand this, it's a lot easier to reason about how to use all of the different APIs, particularly things like Datalog and all of the other query APIs. It also really helps you to reason about scaling and how to deal with really, really large data sets. So I'm going to assume for a couple minutes that you don't know much about Datomic, and start with some basics. And yeah, and it's kind of interesting to keep in the back of your mind what Datomic represents. It's this idea of how do we take these immutable persistent data structures that Clojure has and make a database out of them, where the stuff lives on disk, and it's persistent in the other sense, but you are able to continue working with it as though they are just normal Clojure data structures. And it's actually really interesting if you go into how the architecture works to see all the decisions that Rich and Stu had to make when they built this thing. So the actual data model itself fundamentally is built on this idea of the datum, the EAVT added flag. So this comes from a concept called RDF. I'm not sure what RDF stands for. I just know to say that at this point in the talk. So it's an idea that was borrowed rather than created, like most of Clojure's ideas. And yeah, let's kind of dive into it. So on the E side, which is the kind of the core identity, we have an entity ID, and that's a Java long, and that's pretty much managed by the database. It's very rare that you actually need to work with those directly. Then we have attributes, which are also IDs. Those are integers. We use smaller numbers for speed in this space because we use them so often. And then Datomic has got a nice keyword facade for us humans to work with. Then we've got the value, and then the value is really based on type. You could have lots of different kinds of values here, but the key thing that's true about all of them is that they are scalar values. When you deal with complex data structures, you're actually working with multiple datums rather than some interesting thing happening in the value space. For example, I think Postgres has this idea that you can store JSON blobs in a column and work with it as a JSON data structure rather than a string. That Datomic doesn't do that. It's just it's a box, and you can set the type of that box. The transaction is an entity ID that points to other entities in the system. And then the added is really just a flag to keep track of whether or not this datum represents something that was added to the system, an assertion, a new fact, or whether an existing fact was retracted, removed, made no longer true. And with those 5 values, you can model just about anything. Some exceptions are things like geospatial data, which is something that MongoDB is pretty good at. I haven't really seen a lot of that in Datomic. But you can find that you can model a surprisingly large amount of stuff with these 5 basic things. So what's interesting about Datomic is that its own control structures are represented in terms of these datums as well. So when you create a new database, which I will now do, so I just resetted my database, it should be completely empty. You create a new database, it's not actually empty. There are a bunch of datums already in there, and so we can see that's a supposedly empty database. It's actually got 223 datums. So those datums actually make up all of the primitives that you interact with when you work with Datomic's APIs. When you transact, you're not actually putting new data in the database so much as you're creating new relationships to existing data in the database. Yeah, when you transact a new enum, for example, you're actually extending the ident entity in the database and saying that it is now related to this new enum. If you play with Datomic a little bit, you'll kind of see, that idea come through. But for now, I will just show you that we do actually have a whole bunch of stuff in the database. So let me just print this out and then pretty print it, or not. Can't pretty print it. I have to quote it first. So we can see basically all of those primitives that exist in the database are actually in the database rather than some special hard-coded thing outside the database. Now, of course, they are also hard-coded in the sense that they connect to things in Datomic source code, but they have a data presence. And once you start to get familiar with Datomic and you realize just you're in working with Datomic, you realize just how valuable the data as API concept actually is. And it's really fascinating to see how Rich has applied this idea. Rich and Stu have applied this idea. So I encourage you to dig around in an empty database sometime and see what you can see. So let me just get rid of that. Is a supposedly empty database, and then we can see here, just as an example, that it is just data, and you can talk to this database and get data out of it. We can actually have a look at the datums that make up just the DB doc string entity or attribute in the database. So just to show how it's kind of self-referential, you can see that the entity ID for the doc string schema is 62. And you can see that it refers to itself when giving itself its own doc string. And that is obviously because of something cool happening in the source code somewhere. So that is basically the, just looking at how the Datomic database is built out of its own datums. So if we move on to how we actually put our own data in, just get this lined up. So one of the key things that makes Datomic so flexible is how it allows you to capture your intents about how your data is to be structured. So what attributes do, what schema is, it only governs how it only governs how V's relate to E's, and the A is what captures that relationship. So, in terms of that, it captures obviously the name of that relationship, which is the attribute ident, its type, and its cardinality. And those are the three things that you have to say about every schema definition you create. But you can also say a bunch of other stuff. For example, whether or not it must be in the full text index, whether or not it has a doc string. You can put your own stuff on schema in the database if you want to. One very common one is adding a deprecated flag for schema that you're no longer using. But the really important insight is that Datomic does not just tell you how to compose attributes, multiple A's for an E. That's completely up to you, and that leaves that concern up to you in the application space. And I think it's going to be really interesting once Clojure 1.9 finally lands and it's out properly out in the wild. It's going to be really interesting to see how people use Core.spec to add that layer of deciding which attributes work together and which don't. It's going to be a really interesting time. So there we go, there's that. So for the rest of what I'm going to show you, as we dive into the indexes, I've defined a little bit of schema here. And this is using the newer syntax and the newer version of Datomic, which hides away all of the kind of the underlying gunk that you needed to add. And it actually reads quite cleanly now. So you can see that we're defining 5 attributes. 3 which comprise a person and 2 which comprise an app. This is a completely contrived schema. Pardon me. And we can see that we've got strings, we've got 4 strings, and we've got a ref. So refs obviously allow us to put an entity value on the V side of a relationship. So it basically allows us to create relationships between entities. And we've also said that there's a couple that are cardinality many and cardinality one. So cardinality just decides how many V's a given E can have for an A. So how many values an entity can have for an attribute. And incidentally, the way that Datomic does that, which we'll see in a bit, is it just represents that with multiple datums. So it's kind of like a macro expansion kind of a thing that's happening during transaction time, which is pretty cool. Okay, and then we also see that we've defined some kind of optional things here. So we've said that name or names have to be unique in a database. And that we've also said that application links are indexed for fast lookup. So we'll transact this schema. That's in our database now. And then we just got a little bit of sample data. So again, using the newer temp ID situation. Okay, I see I've got some questions here. So the questions about, okay, so EAVTA, that is the short of something I'm about to show you further down. So I apologize, we will get there. You'll see it in a second. Let me just explain the data and then we'll dive all the way deep into that. Okay, so the sample data very quickly. We've defined 2 people, we've defined 2 apps, and you can see through the use of IDs over here that we've defined relationships between people and apps. So we've said that there's this Robert person who likes coffee and Lego. He uses this thing called Clojure, this app called Clojure, and Clojure has that link. And similarly, there's this person called Ryan who likes cold weather, and he uses this app called Datomic. And so we'll put that in there, and then we'll get to answering those questions. So storage. So what you were asking about there just now, that EAVT. So we'll just very quickly clear that up. So when EAVTA is shorthand for this entity, attribute, value, transaction, and added. So we're going to unpack what these are for the next couple minutes. Just to recover this, just to make sure that it's kind of settled in. So the E is the entity. It's the entity ID. It's a Java long, which is a large number. It is the internal ID, kind of synonymous with MySQL's auto-incrementing IDs in SQL database tables. It's the internal identifier in the database, and it's what everything is linked to for that entity. A is the attribute. It's the name of the value that you want to capture for that entity. So we can see an example here. And then V is whatever the value is. The T is a link to another entity in the database, which represents the transaction that created all this data. So in this example over here, we're seeing that somewhere else there's a transaction with an entity with an ID 1000, and that entity was created when that transaction occurred. So yeah, I hope that I've so entity is, it is a way to model a thing out in the real world. I don't want to use the word object, but maybe I should. It's kind of like an object in the sense that it ties together a whole bunch of key values and brings them together and says, here's this thing with this stuff. Entity is the thing, and the attribute value is the stuff. So can people hear me? I'm seeing sound gone. Ryan? Okay. Okay, so let's get back into it. So these indexes, so the way that Datomic stores this data on disk, it stores basically these datums, these EAVT added flags, which we collectively call datums, in 4 different ways in storage. And these 4 different ways have got names. So there's the EAVT, the AEVT, the AVET, and the VAET. We'll get into what each of those mean in a second. And really what the ordering in the name means is the order. It determines the order that the data are sorted in. And we'll see that play out in a second. Something that's important to understand at this point is the trade-off that the designers of Datomic made when they created the system. They basically said, we prefer to make sorting and indexing quicker, and we were willing to pay by having multiple copies of the data to make fast seek, fast reads, fast index scanning. And so these are what are known as covering indexes, which is to say that all of the data in a datum actually is fully copied into the index rather than being in some common store and then these sorted indexes referring to that common store. This is why Datomic databases are so big. We're at gigabytes of data for our current database, and our previous database was megabytes. But it's okay because we've got lots of disk space, we've got lots of RAM, and bandwidth is cheap these days, whereas CPU will always be expensive because it is time-bound. Okay, so to jump into the actual indexes now. So what I'm about to show you is how Datomic is storing its own stuff. I think it's important for you to understand this because although you may not interact with it in this shape directly, knowing that it is in this shape helps you to reason about the performance of the code you're actually writing. And so just keep that idea in mind that you're not actually going to work with it like this so much, although you certainly can, and there are times when it's helpful to do that, but it's more about knowing what the code you're writing is actually doing a couple layers down. So the EAVT index. So this is the kind of the main one where, well, one of the two main ones, where things are first sorted by that entity ID, as you can see here, and then sorted by the attribute, and then finally sorted by value. And then after that, sorted by transaction. But you'll see in all four of these index, transaction is always last, so we kind of ignore it. And so this is, if you think about data access patterns, this is useful if you have an entity ID and you want to ask about that entity. For example, saying, show me everything you know about this entity, or doing a key-based lookup on entity. So we can see an example here. What I've done is I've got an entity for that Ryan user in the database, and you can see that I've got an ID coming back, a very, very long ID. And then when I evaluate that, what I'm doing is I've got this entity, which is kind of a lazy lookup structure, a wrapper that the Datomic API gives you to walk around the database. And I'm issuing key lookups to it. It implements the map protocols, or many of the map key value protocols that Clojure provides. And I'm essentially just issuing two key lookups to it. But because I have the E, and I'm saying, with this E and this A, give me V, it's using the EAVT index underneath. So I hope that is starting to help clarify the EAVT question from earlier. Please shout if it does. We'll jump over to the next index. This is the AEVT index. So this is kind of like a column database. Now we're sorting first by attribute, then by entity, and then finally by value and transaction. And so this is helpful when you're asking questions, about attributes. So give me everyone with an email address, or give me, find me all of the products with this tag, or something like that. You're starting with an A, and you're looking for lots of E's and V's. And so we can see in this data log query here, we're basically saying, well, there's no inputs, so usually in a data log query, you would pass in a database and some arguments over here. In this one, we're basically just using the implicit database argument. And so just to show you the raw query first, we're basically saying we're starting with two unknowns, which are the E and L, the entity IDs and the likes values, and one known, which is the attribute in the middle. And we're saying find all of the datums that match this pattern, and then constrain all of those datums with this pattern. At this point, we will have all of the E's and the A and no N's. So this first one will use the AEVT index because this particular attribute is not actually indexed, optionally indexed, and we'll get to that in a very short while. So this is using AEVT to find all of those E's and those L's. And then it's using that subset of E's that it's found in that A to find the N's. And then this is, so because we have E and A, we're finding V's and we're walking that index. So I hope that kind of helps. So we can see that just using a little bit of functional programming, we're basically just pulling these values out and we're just sorting them. So just to show you the unsorted set, you can see that Datalog actually returned the closure set of values. And this brings to light a really, really important thing to know when working with Datomic is that if you want things sorted out of the order that they appear in here, you're going to have to do that after your query rather than having some kind of sorting DSL built into the query. There's no sort by in Datalog. You have to do it yourself, which I think is cool. So that is those are the two indexes that every single item in your database, no matter what it represents or whether or not it's a cardinality one or many, anything like that, they will all be in both of these indexes. So that's helpful to know, in general. So if we jump down to the third index, which is where things start to get interesting, it's what we call the AVET index, supporter, or the AVET index for short. So now we're sorting by attribute and then value, rather than by attribute and then entity ID. And as you can imagine, we don't really, as programmers or as consumers of this database API, we actually don't really want to care about or concern ourselves with entity IDs too much. We are far more concerned with the names we give things and those things that we have named. And so, in this case, we've given things the name person/name, and we have these names Ryan and Robert. And these are the values we actually want to work with. They are directly related to our application domain rather than to the technical domain of the database. And so Datomic has given us this wonderful thing called lookup refs, where basically you can provide, wherever you would provide an ID to an API, you can also provide this lookup ref. And as long as the AV is indexed, as long as that attribute is indexed and unique, which we can see in the schema, further above in the example, you can basically plop in one of those values rather than an ID. So we'll just quickly run the pull API against the lookup ref. And so you can see I've given a database and this lookup ref, which could have come in off, off the network. It didn't have to first do an intermediary lookup. There is a caveat though. Lookup refs, if they cannot be found in the database, will throw an exception. And this does annoy people sometimes. So you have to be aware of that. Happily, there is a little Datomic API that you can use to basically do that check for you, beforehand, which will essentially just resolve. So if you want to be defensive about it, you can first do an int ID check and then exit, throw or exit your function early. And if that succeeds, then you can go into your more expensive queries. So that's cool. And so we can see now how this plays out in Datalog as well. So app link, I've told it to be indexed. It's not necessarily unique, but it is indexed. And because of that, this query is actually going to use the AVET index rather than the AEVT index. Now, why is this a thing? Why do we care? The AVET index is opt-in. Only the values that you explicitly index or make unique will be in there. That means that the index is naturally going to be smaller, which means that lookups are going to be faster. Secondly, the sort order makes lookups way faster. So we are going to have data in our database which we will never care to index. Meter descriptions, anyone? There's lots of stuff that we'll just never care about in that way. And so this is really just a nice thing that if it's there, Datomic will use it and it'll make your queries faster. So that's pretty cool. The last index, the fourth index, is also optional, but it's optional kind of in a different way. Rather than explicitly saying, hey, put me in this index, you're automatically put in this index when you use references. So when you create a relationship between two entities, automatically Datomic will put a datum which basically reverses the E and V values. And the index is there. You can talk to that index directly and ask it questions. But most of the time, you'll use it when doing these reverse lookups on entities or similar. So it's for this reason that this index is what is giving you the capability to basically do joins in both directions in data log queries, and it's also preventing you from having to model relationships in both directions. This is what makes relationships bidirectional. So we're looking at this app named Datomic. We're talking to the AVET index for that. Then we're walking the VAET index, and then we're mapping over what we get back. So VAET lookups will always give you a collection, even if there's only one value, because we're walking a many-to-one or a one-to-many or a many-to-many relationship in the opposite direction. There's always going to be many on the other side, and we can see that in this case there is only one person there. So I should have written a data log query which shows this off as well, because in the data log query you would not have used the underscore, because data log just knows how to work with that. But again, this index is there doing that. So the other thing about this is you can see the index is nice and small. It only has the refs, so it makes the process of walking around your database with the entity API or doing complicated, deeply nested pull calls. This is what makes all that stuff fast. There's another index-ish, kind of like an index. It's the transaction log. I'm not going to spend much time on this. Basically, it gives you everything that you would get from calling the detransact function. It allows you to just essentially walk the list of those. The result that you get from walking the transaction log is almost identical to the results that you get from calling transact one by one. We have mucked around with this. We don't currently use it anywhere in our production code. We've always found that using things like time-constrained databases, the history database, we've always found those to work out better. I'm itching to use this somewhere because I think it's pretty cool. So I won't go into too much detail on that. So the one interesting difference about the transaction log, though, is that although we looked at the index for an empty database and saw 223 datums, when we look at the transaction log for an empty database, we're actually seeing no transactions. So there's 3 transactions where all of those initial datums are recorded on, and those transactions are set at the epoch, January 1, 1970. But the TX range will actually exclude those. So you don't have to kind of dance around those transactions if you're iterating over the transactions in your database. Okay, so we've looked at E, A, and V pretty extensively, and how they control the sort order of the indexes, and how those sort orders or those sorted sets power query. But that's only the first 3 in those 5. There are 2 others. So on T is basically something you already mostly know about. It's just a pointer to more datums. So in that 4th position, you can get that value out with Datalog. You can't get it out with the entity API or the pull API, but you can reach it with Datalog and obviously with the datums API. And basically, you can say for any given EAV, you can find out the time, the transaction that occurred, and then you can talk about that transaction and get the timestamp out. So we can see that that was the timestamp that value was created. There's a whole another 40-minute talk just on this idea of things being rooted in a particular point in time. And so I'm going to move on from this. That's the T, and there's a lot of cool stuff you can do with that. And then finally, that added, and I think this is a particularly valuable thing to know. A sip of water. So this added thing, it's basically how Datomic keeps track of what's now and what's in the past. So there are datums with the same. Well, let's actually just quickly go and copy some and make it explicit. So we'll just come down here. So if we had this. So this is an assertion datum with true in that position. And this is a retraction datum with false in that position. And so the way that the database keeps track of this is basically it splits those datums up into 2 buckets or portions. So everything with a true that does not have a matching false datum, that is to say, if the datum like this exists with all of this stuff and there's no datum in the database with all those same things and a false, that set of datums, and that was a real mouthful, sorry about that, that set of datums is the now database. So when you're issuing queries against the latest database on the latest database value for a connection, I think, and I stand corrected here, but I think that you're actually accessing an optimized subset of the indexes overall, and it's that subset of datums that we're talking about here. As soon as you start to talk about past databases where the database is constrained by time, like this, or you're talking about the history database, then you're starting to dip into that much bigger set of datums with false, or datums with true that have a matching false. So that I don't know if I've explained that clearly. I would be very happy to dig into this particular topic in a lot more detail in the unsession if we have one. I do have a picture which I think may help bring this together. And I've also just realized that what I thought would be the first half of my talk has just been my entire talk, because I've got 4 minutes left. My goodness. So here's the picture I was talking about. This is an artist impression, I'm the artist, of what storage looks like. So we've got the kind of the now portion, which is in a mature database, much smaller than the full or the history portion. We've got the 4 indexes, and I've actually mislabeled them, mislabeled that last one in the top right there. That should be VAET. So we've got the 4 indexes, and then within those indexes, we've got partitions of data. So the database partition, which is where all of the indexes, the database's own primitives live, as well as all of the schema you install, lives in that little piece at the top, and that's for fast lookup for those. All the transactions are off to the side. I think it's actually like further along than user data, and then all the user data in its own partition. And you can actually make as many user partitions as you like, which helps with optimizing read. So that is pretty much what I have to say in the time that I have available. I did have a whole bunch more tips and tricks, and I think I'm going to have to save them for the unsession. So I'm going to jump over a bunch of slides to where I think we're done. And so what I hope you got from this is that by knowing how the data is modeled by the system itself and how it's kind of represented internally, it'll help you to think about this stuff like any other in-memory closure data structure, which is really what we want, right? We want to work with maps and sets and vectors and lists and these things that we're completely comfortable with working with, and have many excellent functions to work with those data structures. And the thing is, it's actually true that these are in-memory closure data structures, thanks to the way that the peer library works. But I hope that by knowing a little bit about how it's modeled underneath, that you can work with it more naturally that way. It gives you a major advantage when learning all of the different APIs, and it especially helps you when reasoning about scale. So thinking about, what if I have 1 million of these? What if I need, an entity with 1 million things related to it? Knowing this stuff helps you. So there are a couple of things more to say. So first of all, let's see if we have an unsession. We've got, sorry, there are questions there. So cool, we've got 8. Looks like we've got one. So Ryan, I don't know how we would go about organizing that.
We'll make sure we have breakout time to do that, or unless you'd like to do it concurrent to another session, you guys can self-organize and kind of.
Okay, cool. I'd be happy to roll straight into doing that right now, or after a 10-minute break if people are interested.
Yeah, you can use the Appear In plugin, and if that doesn't work, just ping me on Hallway.
Cool. And then the final thing I want to share is that I recently open sourced a cool little library, which I think will help with understanding what's in your database. This is basically a way for managing those DB doc strings. Really, what I did is I took the doc strings in a database and attached a markdown editor to that. So I will paste the link for this somewhere appropriate, wherever you think that, I guess, in the say something. And you can go and grab that and have a look. There's some really cool Datomic, usages on the Datomic API in there. And I'm very, very happy to take contributions and answer questions and so on. And that's all I have right now. So thank you for listening.